Okay, our last chapter is chapter 11, bonds payable. So a bond is an interest-bearing note. It pays out interest on a periodic basis with the full amount of the bond, face amount of the bond to be paid when the bond matures. So the characteristics of a bond is they typically sell in units of 1,000, and they have a maturity date. Most pay semi-annual interest. There are some bonds that pay quarterly interest, and conversely some that pay annually, but the overwhelming majority of them pay interest on a semi-annual basis. There are term bonds, which is the most common out there. And then there is serial bonds, which spreads the single issue of a bond's maturity date over a period of time. So you sell a bulk amount of bonds, and then a portion of which will mature in 5 years, another in 10, another in 15, and another in 20. There are also convertible bonds that could be exchanged at a point in time for shares of common stock. And then there are callable bonds that if the issuing corporation decides, they can recall it and retire the bond issue. So to solve bond problems, we need some basic information. We need the face amount of the bond, which is the amount that is going to be due at the maturity date. When is the bond maturing? Is it in 5 years, 10 years, 15 years? The face interest rate on the bond, and then the market rate, which is what the bond will sell at. So bonds sell on an open market, and the market rate fluctuates on a daily basis based upon the market's determination of the amount of risk involved in the particular bond. The higher the risk, the more the bond needs to pay. The investors need higher returns for higher risk. So by comparing the two, the market or the contract rate with the face rate on the bond, it can be determined whether the bond will sell for more than, less than, or at their face rate. So if the market rate is higher than the contract rate, so in other words, the market demands more than the bond, this particular bond is paying, then it will sell for less than its face value. It will sell at a discount in order to provide the investor with additional yield to make them interested in purchasing that bond. If it is equal to the face value, the face rate, so in other words, if the two are the same, then it will sell at the face amount. And then lastly, if the market rate is less than the face amount, it will sell at a discount. So market rate equals contract rate, the bonds sell at face. If the market rate is greater than the contract rate, it's a discount. And if the market rate is less, it is a premium. Bonds are typically quoted as a percentage. So a quote in the Wall Street Journal could be 98 or it could be 109. A 98 bond will sell for $980, and a 109 bond, a premium bond, will sell at $1,090. So if they're issued at more or less than their face rate, the premium or discount is then amortized over the life of the bond. And so the takeaways from this chapter are going to be how to calculate a bond and how to amortize the discount or premium. So if we start with a straightforward example, we've got $100,000 worth of bonds issued on January 1, 2015. It's going to be paid semi-annually, and it is going to mature in 5 years. And on that particular date, on the same date, January 1, the market rate was equal to. So that's just going to be a debit. It's going to sell at $100,000, the exact face amount, and a credit to bonds payable, the liability. Then on June 30, when they pay the interest, $100,000 times 12% is $12,000 annually. Half of that is 6. And so every June 30th and December 31st, you're going to book a debit to interest expense and a credit to cash. And then at the end of the 5 years in 2019, you'll finally retire the bond by issuing checks for $100,000. So let's assume the same basic information, only now the market rate is 13. So you're paying the market 12%. That's not good enough. They want 13% because of the amount of risk that they determine are in Western Wyoming Distribution's bonds. So they're going to issue that at a discount, $96,406. So that's a 9/6 and probably 3/8 something, or 7/16, something like that. The discount on bonds payable, and still crediting the bonds payable for the $100,000. So then the amortization of the bond discount is going to occur every 6 months. So we're going to have a debit to interest expense and a credit to discount on bonds payable, slowly whittling away at that amount of discount, that $3,600, $400 amount. There are 2 ways of amortizing: straight line and effective interest rate. For purposes of the final exam, we will be doing a problem with the effective interest rate, and I'll be doing those exclusively in my examples on the next lecture when I do problems. So if we were going to do a simple interest rate, then the amortization is going to be $359.40 every 6 months for the 10 periods. So we're going to still pay $6,000 in cash interest. We're going to amortize an additional $359.40 under the straight line method, and the total interest expense therefore is going to be $6,359.40. All right, what if the bond, same interest, same bond, only the market now only needs 11%? So now you're overpaying the market. They wanted 11, you're paying them 12. So they will give you more up front in cash, and that is the premium on bonds payable, $3,769. Same amortization. If under straight line, you're just going to amortize it for 10 years. This is going to reduce the interest from $6,000 down to $56.23.10 over each of the 10 payments over the 5 years that the bond, until it matures. All right. To calculate the face value of the selling price of a bond, you'll need the face value, whether it pays semi-annual or quarterly interest, and the face interest rate, and the market rate at the time of sale. So the present value is the current value of a future sum of money. And so if you could make 10% interest on an investment and you had $1,000 today, then the future value is $1,100, because you could make $100. But on the opposite end, if you needed $1,000 a year from now and you could make 10% interest, how much do you need to have today? Well, $909.09, because that will pay you $90.91, rounded, and add that to it, and you get the $1,000. In 2 years' time, it's $826.45, because you'll make $82.65 initially. That will bring you 64 cents initially. That will bring you to 90909, and then another year brings you to the 1,000. In the back of your book, in Appendix 1, there is a set of tables, present values. So what this is based upon various interest rates. It is the factors over a period of time. And so the interest rates are across the top, and you can see here in the 10, there's the 90909, here's the 8282645, so forth and so on. That is the present value. Then we have another cash flow. That's what you're going to use to calculate the present value of the maturity of the bond, the $1,000 that it's going to mature at. The second thing, you need to do a present value of the annuity, which is the interest rates, the interest that you're going to get paid. $100 at the end of year 1, another $100 at the end of year 2. Factored in, you get a total of $173.55. So Appendix 2 is got those factors. Here's the 909 that we start with for period 1. This is just adding up the first table's factors. So if you take the 90909 and you add in the 835, you get 173,554, and then so forth and so on. So that's how we're going to price. So let's go back to our $100,000 bond at 12% for 5 years. If the market rate is 12%, then the 100,000, you go to table 1, and you go here, and you look down at 6% for 10 years, 0.55839. And it's 6% because you're paying 12% annually, but you're going to pay it in 2 periods. So it's not going to be 5 periods, but 10 periods total. All right, so that's $55,839. Then you go to table 2 for the $6,000 semi-annual interest payments. That's here. Go to 6% down to 10. You get 7.36009. And that's $44,161. Add the two together, you get the face value of $100,000. If it's 13%, then you've got a factor. You're going to go to 6.5% for 10 periods. That's 0.53273 for 53,273, and then 6,000 times the 818883 is 43, and there's your discount, 96,406. If it was only 11%, then their effective interest rate gives you your premium of 103,769. Now, to amortize this, we're going to use a table. So here's our discount. Here's the face value of the bond, 96,406, as it was sold at the discount, because the market wanted 13%. You're only paying 12. So if you multiply that 96,406 406 times 6.5%, you get 6,266. Subtract that from the 6,000, you get an excess of $266. Add that to the 96,406, because now you owe them an additional $266, because the bond holders wanted this 13% yield. They wanted 6,266. You only gave them 6,000. So add that to what you owe them. Now the bond has 96,672. That times 6.5% gets you 6,284, a difference of 284, and you keep going on and on until the very end. You'll have $100,000. The discount works the same. The discount, you take the 103 and now multiply it by the 5.5, because now they only want 11%. You're giving them 12. So now you're overpaying them, because all they wanted was the 5,707. You're giving them $6,293 overpayment. Now you don't owe them as much. Now you only owe them $103,476. Next 5.5% of that figure is $5,691, a difference of $309. And you do that over and over again until finally, once again, you're at the face value of $100,000. We'll be doing lots of problems in the next lecture, and we'll hopefully fully clarify this. So that's it.